So in this video we can have to discuss about how to rationalize the radical expressions. So how to rationalize the square root functions and let's say the cube root and some sort of the roots of interest based on the actual problem that we have. But what is to rationalize? To rationalize, it means to remove the radical. That is to rationalize. Now, before we go further into the typical understanding of the rationalization, I'd like you to understand about this. Let's say we have the nth root of, now it should be like this. Let's say we have the nth root of, let's say, x to the power, let's say nth root of x. So, how can we be able to remove the nth root for that x? So now, as you can see, as it is here, the only way to remove the nth root is to make sure that the power of x is the same as the nature of the root, which is given as, now should be given as the n. That's the only way to make it actually possible to remove the nth root in that way. So that's the working principle on how we can be able to rationalize the radical expressions. And for instance, let's say we have the square root of, let's say, x. How can we be able to eliminate the square root in that case? So according to the basic behind, you should have to understand that having the square root, it is the same as having the 2 here, but it is a silent. But just have to know that. And I should have to make it possible that the x is here, actually the x here is to have the power of 2. Now as it stands here, it means the x is having the power 1, but you have to make it possible that the x is to have the power of 2. How should you be able to work it up to? So the simplest way is to multiply this one by the square root of x. So which means we'll have it as the square root of x times another square root of x. So now since the roots are the same, it means this is the same as having it as x times x. That will be given as the square root of x squared. So which means in this case we'll have it as the x. So the square root has been eliminated there, as you can see. If let's say we have, let's say, the cube root of x to the power, let's say 4. So how should you have to make it up to have to eliminate the square root? Now should be the cube root if this is the case. So now we should have to ensure that the x is having the power of 3, not that of 4. So if that's the case, then we'll have to multiply this one by the x to the power -1. So in this case, we'll have it as the cube root of x to the power 4 times the cube root of x to the power -1. So in this case, this is the same as the cube root of x to the power 4 times x to the power -1. According to the laws of indices, we'll have it as the cube root of x to the power 3. And that corresponds to have it as x. Hence, the radical has been eliminated. And let's say if we have, let's say the 15th root of, let's say, x to the power 2. So now, what is the expression you should have to multiply this one up to eliminate the actually 15th root? Now this is the same as the 15th root of x to the power 2 times the 15th root of x to the power 3. So now which means we'll have it as the 15th root of x to the power 5, which means in this case we'll have it as the x. So keep that in mind. And I should also have to understand about the conjugate. So now the removal of the radical expression, it's more to do with the conjugate. What is the conjugate? This is the expression to be multiplied in order to remove the root. For example, as we discussed, we have, let's say, the 4th root of, let's say, x to the power 2. So what is the expression to be in product of this one in order to remove the to remove the fourth root. That one is said to be the conjugate. It means we have fourth root times x to the power 2 times fourth root of x to the power 2. So which means this is the conjugate of this one. So that's the expression that will help us to eliminate the fourth root. So that will be given as the fourth root of x to the power 4. That corresponds to x. So this is what you call the conjugate. So keep that in mind. Now, what if we have the addition of the expression that involves the square root? Let's say if we have 2 plus, let's say, the square root of, let's say, x. So what is the conjugate of this expression? Now, simple as the conjugate of this one will be given as 2 minus the square root of x. Let's say if we have, let's say, 5 minus, let's say, the square root of 4. Now should be the square root of 2. So which means the conjugate of this one will be given as 5 plus the square root of 2. So which means this expression will really help us to remove this after a radical of the square root. So see the working principle behind that one, but just have to know that how can be able to deduce the conjugate of the expression. And what if we have, let's say, the cube root of a to the power, let's say, 2. What is the conjugate of this one? So now the conjugate of this expression will now be given as the cube root of a to the power 1. This is the conjugate of this one because it will be the one that will help us to have to eliminate after this cube root. So now you know what is a conjugate in this case. Now, what if, let's say, we have the square root of, let's say, 5 minus, let's say, 7. What is the conjugate of this one? Now, since this is the square root, the conjugate will be expressed upon having the square root of 5 plus the square root of 7. That's how we deduce the conjugate and for the square root. What if we have, let's say, 5? Now should be the square root of, let's say, 5. What is the conjugate of the square root of 5? Now the conjugate of square root of 5 is equal, now should be square root of 5, because if you multiply this, we'll have square root of 5. That will be given as the square root of 5 times 5 to the power 2. Square root of 5 to the power 2, which is the same as 5. So which means the conjugate of root 5, square root of 5, it is the same as the square root of 5. So take note of that. So now how about the conjugate of this nature? Let's say we have a cube root of, let's say, u plus, let's say, the cube root of v. Let's say we have the sum of 2 cube roots. How can we be able to have the conjugate of this kind of the expression? So now the conjugate of this expression, according to the principle behind, it is much related with the way we actually factorize the sum of 2 cubes. Take in mind that if we have, let's say, y to the power 3 plus x to the power 3, now this is the same as having it as x plus y times should be that of x squared minus xy plus should be y to the power 2. So bear that in mind. So now what happens you see is that, let's say we have the y being given as, let's say, cube root of u, and we have x being given as the cube root of, let's say, av. So now in this case, having, let's say, a cube root of u plus cube root of y, now this is the same as having it as should be y plus x, should be y plus x. That's what you have now. So now according to the working principle, now the conjugate of y plus x is given as the x squared minus xy plus y squared, which means the conjugate of now cube root of now should be the cube root of u plus the cube root of v will be given as the x squared minus xy plus y squared. That corresponds to the conjugate of that one being given as now the cube root of 3 actually the cube root of v actually u to the power 2 in the minus now the cube root of u times the cube root of v in the plus the cube root of now should be this cube root of actually v to the power 2. And of course let me have it proper here. So whichever the case, the conjugate of the cube root of u plus the cube root of, let's say, v will not be given as the cube root of u to the power, let's say now 2 in the minus now the cube root of u times v in the plus the cube root of actually the cube root of v to the power 2. That is the working principle if we have the sum of two cube roots. So this will be given as e.t.c corresponding actually a conjugate. Now what if we have if we have the addition of two cube roots? What if we have the difference of two cube roots? So now the working principle, it is like this. Of course it is much related, much as the sum of two cubes and different two cubes is also much of related, that it is also that of much related. So what if we have the difference of two actually cube roots? So what will be the conjugate for that one? Let's say we have the cube root of u minus the cube root of, let's say, v. So in this case the conjugate of that one will be given as now the conjugate will be given as the cube root of u to the power 2. Now we'll have a plus the conjugate actually the cube root of actually u times v and that of plus the cube root of actually a v to the power 2. That's the working principle behind the conjugate of actually different two cube roots. So which means if we have the addition of two cube roots, this is the conjugate, and the different two cube roots, this is the conjugate. So keep that in mind. So let us see the way we can have to rationalize the following problems in that case. So we should have to understand on how we can be able to rationalize, and there are some typical problems in the following cases. And for instance, let's say we have, and that should be, let's say we have 4 over 2 plus the square root of 3. So how should we be able to rationalize or remove the actually a square root on the denominator? Or in other words, how should we have to rationalize the denominator? So we'll have to multiply this one by the conjugate of the denominator. But what is the working principle? You should have to understand that the rationalization of this expression will be much of, we'll have to say 4 divided by this one times 1. That is the same as that. So where 1 corresponds to the conjugate of the denominator. So what is the conjugate of the denominator? We'll have it as now 4 divided by 2 plus the square root of 3, which is times 1 actually 2 times 2 minus the square root of 3 divided by 2 minus the square root of 3. So this is the conjugate of the denominator. So in this case we'll have it as, now should be 8 minus, should be 4 times the square root of 3 divided by, now I should have to expand here. That is 2 times 2, we have it as 4, and that minus 2 square root of 3, just that, and that plus 2 square root of 3, just that, then minus, what is the square root of 3 times that of square root of 3? We have it as 3. So now this and this will cancel, which means we'll have it as 8 minus 4 times the square root of 3, and divided by, we have 4 minus 3, that will be given as 1. So which means we'll have it as the 8 minus, should be 4, and the times the square root of 3. So that is the solution. So what if we have, let's say, the square root of x and the minus the square root of 3 divided by, let's say, x plus 2. Now we should have to rationalize the numerator here. So what is the working principle? Have it as times 1, where 1 represents the conjugate of the numerator. So what is the conjugate? We'll have it as the square root of x and minus the square root of 3 divided by x plus 2, and the times, now the conjugate x plus 2, actually a square root of x plus the square root of 3 divided by the square root of x plus the square root of 3. So as you have to understand is that this one are the same, corresponds to 1. That's why we are having times 1 there, because we know that nothing is changing. So keep that in mind. So which means we'll just have to simply multiply this and that and this and that. You'll be able to rationalize the numerator there. You see that on the numerator we will no longer have the squared there. And also think about this one as well. What if we have this case? Let's say we have 1 over the square root of, let's say, 5, and let's say plus, let's say, 2 times the square root of, let's say, 50. Now how should you be able to rationalize the square root on the denominator here? So first thing, we should have to rationalize this one separately. So in this case we'll have it as 1 over square root of 5 times the square root of 5 times the square root of 5. That corresponds to the square root of 5 divided by 5. Then I should have to simplify that one using the SATs. So what is a square root of 50? So this is the same as 25 times 2. That corresponds to have actually 5 times root 2. Yeah, of course, that's the way. So now which means that corresponds to have it in this way. So which means we'll have it as root 5 divided by 5, and the plus will have 10 root 2. So in that case, then you should have to express this one as the single fraction. You see that we'll have what we are looking for as the rationalized expression. So take note of that. So what if we have, let's say, this case, let's say we have 1 over, let's say, 1 plus the square root of 5. So try to rationalize this expression. You also have to try this as well. What if we have, let's say, x divided by the square root of x minus 2? Try to rationalize that one, the denominator itself. What if we have, let's say, square root of x and the minus 2 square root of y divided by, let's say, a square root of x and I plus 2 times the square root of 5. Try to rationalize the denominator here. So work it out. And what if we have, let's say, this case, we have, let's say, square root of x divided by, let's say, square root of a, and the plus the square root of x. So try to rationalize the denominator there. That is in that way. And also let's try to go over the following problems. And what if we have this case? Let's say we have to rationalize this one. Let's say we have a 3 over 4th root of, let's say, 3. So how should you be able to rationalize this actual denominator? So what is the conjugate of this one? So have it as now 4th root of x, actually 4th root of 3 to the power 3 divided by the 4th root of 3 to the power 3. That will mean as now have 3 4th root of 27 divided by a 4th root of 3 to the power 4, which means now should be, we should have the 4th root of, no, this is the 4th root by the way, so which means in this and this will go, we'll have it as 3 4th root of 27 divided by a 3. So that's how we rationalize that one. That's how we should have to rationalize that one that way. Now what if we have this case? Let's say we have 2x over, let's say, the 15th root of, let's say, 16. How should you be able to rationalize this expression? So what is the conjugate of this one? So in this case we'll have it as a 15th root of 16 to the power 4 divided by the 15th root of 16 to the power 4. All we need is that we should have a power 5 on actually as the power of 16. So which means we'll have 2x times the 15th root of 16 to the power 4. Of course we can be able to simplify that one, and that divide by the 15th root of 16 to the power 5. So which means in this and in that one has gone, you'll be able to have it out. That board, if we have this case, let's say we have you should have to try this. Let's say we have it as, let's say, the cube root of 5 divided by the cube root of, let's say, 6. So how should we be able to rationalize, let's say, the numerator if that's the case? Let's think of rationalizing the numerator. So what is the conjugate of this expression? Or have it as the cube root of 5 to the power 2 divided by the cube root of 5 to the power 2, which means we'll have it as the cube root of 3 and 5 to the power 3 divided by the, now the cube root of 6 in the terms we'll have 25. So simplify that one, we'll have it as 5 divided by whatever we'll have down there. So that's the working principle behind actually rationalization. So what about if we have this case? Let's say if we have this case, let's say a over c, and that divided by, let's say, a to the power 2, now should be the 4th root rather, and let's say c to the power, let's say, a 2 as well, and we have b to the power, let's say 3. Let's say this is the case. How should we be able to rationalize that one? So what is the conjugate of 4th root of 8 to the power 2? Or have it as fourth root of a to the power 2. How about this one? Also to the power 2. This one now should be a fourth root of b to the power 1. So which means we'll have it as this case. We'll have the fourth root of a to the power 2, because we know that if we multiply the 2, we'll have a to the power 4 and c to the power 2 and the times b divided by the fourth root of a to the power 2 c to the power 2 times b to the power 1. So which means we'll have it as ac times the fourth root of a square c square times b divided by, so have it as the fourth root of a to the power 4 c to the power 4 and b to the power 4. So which means the square root of, actually the fourth root will go, we'll have this one divided by acb. So that's how we work it up to. Now you should have to try this at your own time. What if we have, let's say, this case? What if we have, let's say, 1 over, let's say, the cube root of, let's say, a minus the cube root of b. So in this case, what is the conjugate of this one? So now we have the difference of two cube roots. So try to have that and out the way we discussed on the conjugate of this one. Also try this as well. Let's say we have it as, let's say, 1 over, let's say, the cube root of a minus, let's say, 1. So what is the conjugate of, by the way, having this one, you should have to understand that this is the same as the cube root of 1. So it can be that. That is the same as that. So try to rationalize that at your own time. And what if, let's say, we have this case? And try to go through this. Let's say we should have to rationalize, let's say, 3 over fourth root of 27 and the 8 to the power 5 times b to the power 11. So try to go through this and see how best we can be able to rationalize that one. So thank you.